People all around the world are living the high life. That's to say, living their whole lives at high altitude. This lifestyle has an impact on their bodies, including upon how their bones grow. And one adaptation, Cambridge University's Stephanie Payne has found, is to alter the relative length of the arms. So, Stephanie, who did you study and why?
We studied two populations in the Himalayas, a group of Sherpa people living in the highlands of Nepal and a Tibetan group living in the lowlands of Nepal.
And I'm going to ask you why those people.
So they've been living at high altitude for several hundred generations. And the Tibetan group, whilst they have been traditionally living on the Tibetan plateau, now they live in lowland regions. They have the same high altitude ancestry, but they've been exposed to the low altitude environment.
OK, so what were you measuring?
So we were measuring upper limb proportions. So we measured upper arm, forearm, and hand lengths with what's called an anthropometer, which is a fancy tape measure, and also height.
OK, and what did you find with these measurements?
So we found that those living at high altitude tend to have shorter forearms than those living at low altitude, but the upper arm and the hand were the same length.
Why do you think this has happened then?
We've got one idea or hypothesis, which is we think the body might be being thrifty with the energy that it has.
What do you mean?
So at high altitude, there's very limited oxygen, and that means that there's relatively low amounts of energy to use for growth. And so we think the body might be prioritizing where it uses its energy to invest in the most important parts of the body. For example, the hand, which is really important for manipulation, and the upper arm, which is very important for strength. And as a result, it compromises growth in the forearm.
You're just looking at people from a specific region here, but is this generalisable to other people who live at high altitudes?
Potentially, yes. We have some colleagues who've already discovered this in Andean populations. We've got to find more, so potentially we need to look in places such as Ethiopia, etc., to see if this is a pattern we see in all high altitude populations.
Are the legs affected in the same way in terms of which bit of the leg, Steph? Because you mentioned that the arm is spared in the upper arm to give strength. Do you see the same effect in the leg?
Yes, that's right. So we see that the shin bone or the tibia is significantly shorter as well, so the same proportions.
If you look at other populations who are living in particularly harsh environments, just not high altitude, do they also show size differences in the same sort of way? Because if the body's being thrifty with its energy, as the way you're saying, then it shouldn't really matter if it's just altitude that's the driver.
Yes, this is something that we have still yet to look further into, but is a really exciting avenue for future research.
Did you get to go to the Himalayas and measure these people, or did you just get someone else's data?
We went all the way, trekked through the mountains for 2 days in order to get up to Namche Bazaar, where we started our research.
That sounds amazing. I'm rather jealous, to be honest.
These things these scientists do, and they call it research, but...
Well, I ended up getting altitude sickness, so didn't feel so happy about it when I was up there, but very grateful we still got the data.
We'll have to leave it there. Stephanie Payne from Cambridge University, thank you. And the study was published in the Royal Society Open Science.